thanks, Steve, so much for joining us.
Yeah, thanks for having me.
Yeah. So we're planning to run more of these webinars every couple of weeks, and I'm happy. Like the first one is about MCP. It's a really cool project, and yeah. So first, we're going to start with like an introduction to MCP. What is MCP, and like how it works, some details about the protocol, and then we'll hand things over to Steve. So Steve would tell us more about like what they're doing at Kemet Trading. So Steve is the head of platforming at Kemet Trading. So like for some reason when I like when I say platforming, I picture like the 2D platformers.
Little side scroller.
Yeah, so like head Super Mario, bro. Yeah. So yeah, we can just start. Yeah, and this also will be recorded and available on YouTube afterwards. So yeah, perfect.
Cool.
Okay. So I need to find the right panel switcher. Okay. So let's start. So what is MCP? Okay. Just getting the hang of it. Okay. So what is MCP? So the best way I think, like, or the best analogy for what MCP is comparing REST API to GraphQL. So I'd like to think of MCP as GraphQL, where initially when you were trying to build an app and this app connects to multiple APIs, you would have to build a local client for every single API. So if you're trying to build some automation internally to connect with Slack, GitHub Actions, and your AWS account, you'd have to implement that, take the SDKs of these APIs, and then build your custom integration. And then your front end will be able to connect to these different tools through these SDKs. So how GraphQL makes something like that easier is that you can add a single GraphQL server on top of like existing APIs, and then you would have a GraphQL client that connects to this GraphQL server with a different protocol, which is like GraphQL. Like everything goes through a post request, and by doing that, you basically like aggregate all the external APIs and your existing data sources and expose them through GraphQL server. So regardless of what front-end application you're building, whether a web app, client, mobile app, you'll be able to get the data you need across these APIs without having to implement a client and without having to specify beforehand the exact use cases to code these clients. So you just use like this generic API to aggregate everything and just use it. So in a sense, MCP is like that, like GraphQL. It's a protocol with a client and a server that you add on top of your existing APIs, and you implement this client inside like your host or like LLM application, and it gives you access to these APIs. So how does LLM apps look today? So it's exactly the same thing as I described for the regular REST APIs. You have built an LLM application. This application can be Claude Desktop, where you're chatting with Claude locally. Can be OpenAI client on your or like macOS app or your mobile app, or it can be a coding assistant or Cursor, for example, if you're into like AI native coding. And these applications, they build custom integrations for different things. So if you want to, your Cursor or like your GitHub extensions or like a GitHub environment, VS Code, VS Code and GitHub Copilot, to be able to integrate with Slack or GitHub, you have to add extensions to give it access to that. And you have to change the code of the VS Code GitHub Copilot extension or Cursor to be able to add third-party integrations or like just add plugins and somehow allow like the coding assistant to access these APIs. Because most of us don't have access to this code and we can't do this high level of customizations in these integrations. It's super difficult at the moment to extend any LLM app to support other integrations. And for the integration side of things, like every single person or developer building an LLM app would have to maintain their own integration with these APIs. What MCP does, which is like the model, it stands for Model Context Protocol. It was released by Anthropic like a couple of months ago. It basically adds a layer, like the GraphQL layer, where you have like an MCP server that integrates or like implements the details of working with an external API, and then exposes it through the MCP protocol to an MCP client. An MCP client is like the SDK you would use to interact with a specific API. And this, like, it feels like over-engineering or like an added API for your API, but actually makes things easier because Slack can implement their own MCP server, and then any MCP client that supports the MCP protocol can integrate with it. So any LLM app that implements the MCP client and supports the same protocol version can actually use any existing MCP server with the same compatible version. So something like Claude Desktop or your coding assistant that supports an MCP client can just like hook up to any server and just like interact with this API. whether to fetch data, call tools, we go like into details, or like create GitHub issues or scan your GitHub repositories, for example. And the MCP client is actually generic. It works with various LLMs, so it doesn't work only with Claude. You would find something like Cursor, you can work with OpenAI and still integrate with different MCP servers. So MCP made things easier by adding this additional layer of indirection that allows you to implement these servers once and implement a client and then integrate them together. So what does this mean? If you're a developer and you're building something, whether it's an API and you want to expose this API to existing LLM applications, or whether you're building an LLM application and you want to add support to all the existing MCP servers. Like there are literally hundreds of MCP servers integrated with a lot of APIs out there, and you don't have to rebuild old integrations yourself. So to be able to do that, I'll walk you through the protocol. So the first part about the protocol. So this is like a very superficial introduction. You can find all of these details in the documentation to dig deeper if you want to, and like with implementation examples and existing SDKs. So the first thing you should know is about like the transportation layer. So to implement the MCP protocol, it's just like a JSON protocol, JSON messages using JSON RPC, which is like remote procedure call with JSON objects. So basically just like a standard for creating function calls using JSON over HTTP. But in this case, like the MCP supports at the moment two transport protocols. The first one is STDIO, which is like the dumbest transport protocol ever, which is like standard input and output. So what happens here is just like the client, you just feed it a JSON as standard input and then get the output as a standard output and just use it as JSON. So it's basically a string in and a string out, and you just run this locally. Or the extension, the MCP client runs this locally. The other way to do it is over an HTTP endpoint, which is the more convenient way of doing this, which is just like connecting to an HTTP server and sending the exact same like JSON RPC requests and getting a response. So it's just like a standard remote call, remote procedure call, like calling a remote function over standard input output or JSON RPC. There is a proposal for remote transport where you can do this like over the internet in a secure way. So here, like the HTTP transport gives you like it seems like it's doing this over the internet, but actually most of the MCP server integrations built with this HTTP transport are just running local servers on your machine. So it's just a local server running on your machine, and it's proxying these requests to the external API or like external resources, but you're communicating with it, your client is communicating with it over HTTP. So the first part of the MCP protocol is discovery. Similar to how GraphQL does discovery. So if you like use the GraphQL editor or playground, like provided by most of the frameworks out there, you would see there's an explorer feature where you can explore the API, the data structures, and how you can interact with them, or like the mutation and how you can change the data and so on. So the same thing is implemented by the MCP protocol. So as you can see here, like this is a JSON RPC message with a method called initialize. So the host with the MCP client, which is the LLM application, which could be Claude Desktop, IDEs, existing tools, any tool that implements the protocol, sends an initialization request to the MCP server. And this request basically declares the capabilities of the client, what version it supports, and the existing capabilities of the client. We wouldn't dig deeper into that, but you can check it on the documentation. But most importantly, the server responds with its available resources, prompts, or tools. So MCP exposes existing prompts or prompt templates, resources, which can be a file. So basically reading stuff. It's not like it shouldn't have any side effects. Basically returning file, returning data. And there are tools. And these tools can trigger side effects or like make something happen, like create an issue on GitHub. So to give you an example here, like a prompt can be a prompt that your LLM application is going to use to generate GitHub commits. So then you can commit your code. A resource would be a list of GitHub issues on a specific project, or like code files, for example, in your repository. And a tool would be like a web request to the GitHub API to create an issue or close an issue. So you would use basically the three different kind of capabilities when you're interacting with something related to your development flow in GitHub. But you don't have to implement all three. You can only have prompts or resources or tools. So let's break them down one by one. So the prompts, there's a JSON RPC call, which lists the prompts, and you can expose these prompts. And the cool thing about this, they're not just static prompts. You can templatize these prompts. So if you inspect this, like I know the font is a little tiny, but like if you inspect this, in the documentation, you would see like you can list the prompt, you get the prompt name, and you get a description, and you get arguments for this prompt. So, for example, like this prompt is a code review prompt, and it says asks the LLM to analyze code quality and suggest improvements. And this prompt takes an argument called code, which is the actual code to be reviewed. So in this case, this prompt, when we're calling it with a GET request, we'd give it the arguments, like fill in the code argument, and then we'd get the end result, which is the entire prompt, the built-in prompt with the code appended to it. So this is a way to generalize templatizing prompts. So you can have your own set of prompts and add parameters, and then call these like the endpoint, and the templating would be done on your behalf with the MCP server side of things. So you can store prompts and share them like with other developers and other people externally. This is incredibly useful for your own products because like not all developers or engineers know how to prompt properly, and like the same thing happens with all people. Yeah, specifically engineers, we most of us are pretty terrible at prompt engineering, but like most people in general, like it has a learning curve, so you can learn to prompt the AI well. So having some predefined and shared high quality prompts improves like adoption of these tools within your organization and makes it easier for users if you're building something like an MCP server or an API that you want to expose through an MCP client, like using an LM application. So this is the first thing, prompts. The second thing is resources. So as we said earlier, like resources, they are like resources do not have any side effects. They're usually data. So people use resources to expose things like listing directory files, getting access to a bucket, like querying some data from a database, whatever you have in mind. But like the resources don't have side effects, so they usually read operations to access external resources and to give the LLM application more context. So there are mainly three actions within the resources. The first one is listing the resources. So like this is the response you get. For example, like you have a URI for the resource. Here, the resources is a Rust file. So there's a file column and then double dash, like defining the protocol. So this is like a valid URI, and then the name of the file, and the name of the resource description, and the MIME type of the resource. So this doesn't return the resource content itself, just lists the available resources. And you would find there's another version of this list endpoint that's called list templates. And you would think, okay, if I can list resources, and I want to list a file system or like list a pattern, get a pattern of the possible resources. So then I can take this URI and fill it in with some parameters and like query more resources. And this is what happens with the template. So as you can see here, like the URI template instead of a URI, which gives the user or the LLM the pattern of the URI supported by this MCP server. So then it can create subsequent queries with specific parameters, parameterizing this template to be able to fetch stuff. So here, for example, you can show the user like a specific directory instead of a specific file. So then the user can follow up with another like resource request fetching a specific file within this directory, for example. Finally, there's the get, like the get request, which fetches the actual resource. So here you would see the MIME type and the actual text of the Rust code. Finally, and most importantly, are the tools. So if you're familiar with LLMs, you've built LLM applications before, LLMs allow you to call external tools. And the way this works is you define a schema for the input for these tools. The LLMs generate this input, and then you execute the function using this input externally, and then provide the output back to the LLM. So you can do the same thing. If you're building an MCP server for your API, or you're using existing MCP server, they usually expose tools. And these tools have a specific schema on how to call the tool and a name and a description, which is used by the LLM to decide which tool to call. And then you can call the tool through the MCP integration, which calls the actual tool with the input and gets you the output. So you would use resources for static, no side effect, kind of fetching data or context. You would use prompts to help you prompt the LLM, like fetch parameterized or templatized prompts. And you would use tools to do stuff with side effects, like creating a GitHub issue or like modifying, like committing a code or something like that, or creating a database migration, whatever. So that's the cool thing about MCP, like you can do any of that. So here you would find in this repository our own like open source implementation of the Stakpak MCP server as an example. It's in TypeScript. So you can check the source code and look it up yourself. You can scan this QR code or just like go to Stakpak MCP. It's also available as an NPM package if you want to try it out. Maybe it has just a single tool at the moment, which is like generating Terraform code, but I'll give you an example of how you can build this. And I would recommend also going to the official model context protocol documentation because it's amazing. There's also a very cool Farship video on how to build this from scratch in like a couple of minutes. Finally, what's next for MCP? So you would find a lot of stuff on the development roadmap for MCP. But the two things I'm very excited about is the remote MCP. So basically being able to implement the server on like Cloudflare, like hosted somewhere else on a serverless endpoint or something, and then like be able to connect to this MCP server remotely instead of having the user install it. Because now if you go to like the GitHub project here, you would see like most MCP servers and the Stakpak MCP server as well like works with an npm package, so it runs using npx. And that's not very convenient because not all environments might have npm installed. So having this remote server would make it more convenient and would help you update the code without having to like communicate on the web page or like have your users use @latest, for example, for the package, so they can get the updates. Another thing I'm very excited about is the streaming results support. So now when you make a tool call over MCP, you just have to wait until it's done. So if you're calling Stakpak MCP server, for example, generate infrastructure code, it would take 30 or 50 seconds at some point, and you're just waiting. But like with the streaming results, you'll be able to see the progress as it's generating stuff token by token, for example. So I'm really excited about that because then it would have like a much more like a better user experience, and like developers hate waiting for stuff. So that's very cool. Yeah, so you can ask me. So that's it. So you can ask me before we go on to the case study in like on YouTube Live or LinkedIn, any questions you have, if you have any questions about this. If not, we'll go with Steve, who's like head of platforming at Kemet Trading. So yeah, let me add Steve to stage. Introduce him. Yeah, so here's Steve. Thank you so much for joining us, Steve.
Yeah, thanks for having me.
Yeah, do you have any questions, Steve?
Do I have any questions? That was a wonderful walkthrough. No, I really like the analogy to GraphQL. I never put those two together. I've played with both, obviously. And that's a really good analogy that can really drive the point home on just kind of how these interactions behave. And I too am looking forward to the remote MCP. It's a pain to have everybody have to run npx and then get all that configuration locally, rather than, especially being on the platform side of things, I like being able to host it myself and take care of all those concerns, and then the engineers can just plug right in. So totally agree.
Cool. So can you just at least tell us a bit about Kemet and what you guys do?
Yeah, so Kemet Trading, we are a platform for trading derivatives in the crypto space. So we basically provide a single pane of glass that interfaces with a number of different exchanges and allows very mature, proprietary trading firms, hedge funds, to be able to run very advanced execution across multiple venues. We have algorithmic execution. We have some arbitrage type features. We also provide a very clean portfolio management service. You can see across all the venues your overall exposure to all of the cryptos, and then of course the risk associated with that.
Interesting. Very cool. So like, how big is your development team at the moment?
So engineering as a whole, I believe we are at 12 now. My team, myself, on the platform side, it's just myself and 2 other engineers. So pretty lean.
Yeah, that's cool. We're very pretty lean as well. Yeah, I'm the platform team here as well. Yeah, but we're using Stakpak to run Stakpak, so we're kind of cheating.
Agentic has changed everything, that's for sure. Especially when trying to build a team into the future, it changes a lot of decisions you make, for sure.
Yeah, can you tell us like how it changed things for you? Like, how do you start incorporating more LLMs and agents in your workflow? And like specifically, like let's start with that, but then specifically tell me like what part of how are you using MCP at the moment?
Sure. So like many teams, I imagine, we got our first taste of some of this through Copilot. And just, especially on the configuration management side of things with Terraform and Kubernetes, it basically functioned for us as kind of a super powered autocomplete, which, okay, fine. It's valuable in that, but not much more beyond that. Really, though, when we began to look at agentic workflows and agentic solutions, specifically Cursor, it changed everything, as you might imagine. And like many teams, when they're first going through this transition, everybody will say, oh, it was this big productivity increase and all these things. What they skip over is the first initial, probably week and a half, where everybody's having to rethink how they do things. And oftentimes I think we kind of skip over that. So there was a bit of a learning curve as we kind of reformulated how we went about our SDLC, if you will, on both the infrastructure side and the product development side. So we started off with Cursor. And again, especially with the types of things that we deal with in the platform/DevOps world, again, really great for getting things stubbed out. But configuration management oftentimes is not something that you can, just abstractly put in place. You need to provide the concrete values. You need to work through a lot of these things that, of course, Stakpak is solving for. So using just a blind LLM, something like using Sonnet in, say, Warp. So we use the Warp terminal as well. If I were to ask it, for some things about different versions, you can get some very bad information out of that because you're scoped to whatever it was last trained on, and these versioning type things run stale. So really, what MCPs began to solve for us at the very early on was, how do I keep things fresh while built on this existing LLM solution? So in our day-to-day flow right now, when it comes to things like complex migrations, runbooks, we use the sequential thinking MCP that Anthropic provides. I will encourage everybody to look at mcp-get.com. There are a whole host of solutions out there to play with. We are very specific in the ones that we incorporate because there's a lot of security risk involved. And in our space, we have to be very cognizant of that. But as a wonderful playground to go and explore some things. The opportunity to have an agent respond to the iMessage messages coming in from my mother, I still haven't done, but it certainly would be useful. But back to Kemet. So sequential thinking has been a very big benefit for breaking down complex tasks and really putting those things together. I, especially on the operations side of things, hate having to write runbooks. I hate having to make those arguments, and getting some output that gets us 95, 98% of the way there is fantastic. The other one that is really helped us, fast moving company, lean team, we have a lot of change management that we have to deal with, and that involves high cognitive overhead, and that involves frequent iteration. So being able to plug into the GitLab MCP and move projects around, restructure things, refactor code, not just within the scope of a particular project that we have in the context of the Cursor editor, but remotely as well into GitLab, has been very beneficial. So it's now kind of our de facto go-to is, okay, if we find something that the current solution is insufficient in supporting, then what sort of MCP could help solve for that? One that I'm excited about that I haven't played with yet is the memory MCP that Anthropic provides, which allows you to provide a way for persisting things to a persistent context that it then can recall in subsequent sessions, which I feel is very overpowered and it could be very exciting.
It feels like developers will be building their own kind of like coding assistant with their own mix of extensions and their own like setup, which is super interesting. Like it feels like the future are like customized coding assistants for your specific own workflow. Like you're having a mini Steve minion that built with your own like set of extensions that does things your way. Interesting. So Absolutely. I've never heard of the sequential thinking MCP. Like what does it do? Like can you tell us more?
So it's very good for taking a complex task. So we manage give a little bit about our stack. So we manage multiple Kubernetes clusters globally, all within a single repository that we then use Flux for GitOps type continuous deployment into those clusters. And doing a migration across clusters is something that involves a lot of context that isn't immediately present in the code base. There's hostname migrations, there's data migrations, there's downtimes, there's all these additional things that aren't in the context of the editor immediately clear. But if you provide it enough context and say, this is the type of thing that I need to do, we need to migrate this from here to here. And the simple solution is, okay, well, then you just move the code from this portion of the hierarchy to this portion of the hierarchy. And that's from a code change, all you really need to worry about, setting aside all of the operational concerns. So if you give it the very specific prompts of think through this step by step. I need to migrate this Kubernetes cluster from London to Paris. It involves AWS infrastructure. It involves, give it all those usual, we use kind of predefined that we've developed cursor rules that we add to all of our projects to, prompt it and put it in the appropriate context. But give it that guidance, and it will sit there and iterate and iterate and iterate and develop in a very sufficient run book that you can then just copy paste. We drop it in Notion, we refine it a little bit, share it with stakeholders, boom, done, throw it in the Jira backlog, and we're ready to go.
Can you feed these runbooks back into like the extension so it can use it in the future?
I would imagine. So you can also ship it to Notion through their own MCP if you really wanted to. Didn't do that. Haven't dealt with that. I found that a sufficient one, honestly. They aren't using the querying aspect of getting the set of capabilities. They're just very narrow scopes, like to-do type things. So they're toys right now. But in the very near future, it should be very easy to plug in all of these third-party services that we all have to work with on a daily basis. And really that agentic iteration, we're already feeding it back into Terraform plans and having it deal with the errors coming out and correct that from there. And so it can kind of refine itself. But being able to plug it into all these other services would really turn it into right now I describe these things as, junior developers that you have to argue with a little bit, which is perfect. That's okay. But they can become senior engineers very quickly if we give them all of the tools and give them the appropriate prompts. And that's where I think, especially by extending these LLMs with MCPs, where the real power is going to reside.
Very interesting. So one thing we've tried about this, is we're trying to run DevOps agents to do specific tasks end to end, and then take the output or the plan or the sequence of actions it took, and then try to pipe this into a retrospective script that would generate retro out of it. So then we can feed it to an agent. This didn't work at all. It broke everything. So what we found that works really well is, instead of trying to build this as a retrospective document, to build it as an SOP or a specific standard operating procedure or runbook. And then if you feed these runbooks of the golden path into making something happen into the agent, it tends to bias the agent into performing better because it sees a golden path or a great example to copy. And sometimes this makes them more efficient. So I would imagine if you're getting these runbooks as an output and documenting some of them, and then being able to feed them back to the agent, this would increase the success rate a lot. It's interesting. So the thing I've found the agents really good at is coming up with the next command I should write and the sequence of commands. For example, if you're trying to expand disks on AWS on a Linux machine, for example, you need to increase the disk size on AWS, and then you have to do remap the directory within the machine itself. So the sequence of commands, and I always forget them because I tend to do this 3 or 4 times per year. But it's much faster in coming up with the next command and much quicker than I would the time I would take to Google it and then go back to it. And then after it comes up with the sequence, and if I'm storing the history, then I can just export a bash script out of it that would be able to help me in the future, sort of a runbook. To be able to do that. So I've been experimenting with runbooks as well. It's really nice. But you mentioned a couple of times things related to security, because you're using an existing MCP server, you're not sure who wrote it, and this can be a huge supply chain risk. And also you mentioned creating rule books. And I think someone just published an article about injecting malicious instructions through rule books to make cursor call home or write malicious code or embed backdoors in your code. So it's quite scary. So what do you guys do to handle this kind of risk when you're using these workflows?
I mean, right now, that's why we have a limited selection of MCPs that we are playing with, honestly. Beyond that, we haven't encountered anything that would be causing any red flags. So we kind of use them, I think of it more as okay, the client, especially running, is just treated like a little proxy, or the server running locally, treated as a proxy to these APIs. And okay, fine. And we are trusting that the authors of these are good actors, and so that's why we stick to the ones that are published by Anthropic. But that being said, as this technology takes off, as it gets broader adoption, there will be plenty of really good community solutions out there. And just like vetting any other open source solution, it's going to come down to software supply chain type concerns. I'm sure I haven't gone into it because we don't develop LLMs, but I would almost guarantee, especially with some of the open source models that are out there, DeepSeek Plus, you're going to have these software supply chain concerns that are going to be solutions built around to help solve for it. I'm hoping.
Yes, I think somewhere on the roadmap they have something related to like packaging and like package management and distribution for LLM servers. Maybe they involve some digital signatures there where you can like create like a trusted package and then distribute it and verify it. But like, yeah, hopefully that will get out soon because there are like thousands of MCP servers already to try from.
It's where we're at in the adoption cycle, but it's also one of the most exciting things about getting involved in this space, both as a developer on the LLM and MCP side, and also as a consumer trying to use it to accelerate your flows. It's all driven by your risk appetite and your ability to adapt to what you're building.
Yeah, amazing. I mean, super exciting. Yeah, thank you so much, Steve. This was very informative. I really hope we do another one, and then you would show us like your workflow and like the fun books we're creating.
Sure.
Because like, yeah, I'm like, yeah, it's crazy, and you're one of the very early teams adopting this heavily and trying to build your own custom workflow. So it's super exciting.
Yeah, thanks. I'm also keen to see, as Stakpak evolves your own MCP, you guys are solving a lot of the problems that we've had with, especially the Terraform type configuration management and the Kubernetes. You're solving for those problems. So that's exciting as well.
Thank you so much, Steve. Yeah.
Yeah.
Thanks so much for joining me today. Yeah. Have a nice day. Thanks, everyone. Bye.